My name is Mihail Mateev. I'm Solutions Architect working on Microsoft Azure and IoT nearly 10 years. I'm also community enthusiast, Microsoft MVP, member of Regional Director Program, and Microsoft Certified Trainer. In this session, we will talk how to build modern IoT solutions with Cosmos DB and Power BI. It is something which is probably very interesting and unusual because Power BI and Cosmos DB are mostly related to Microsoft Data Platform. But IoT is actually data-centric type of systems, and you will see how it's possible to integrate and make analysis with Power BI, how it's possible also to use Cosmos DB for data persistence in different scenarios. Hope that you will enjoy this session. During this presentation, we will talk about IoT solutions common use cases. We will talk a little bit more about Azure IoT solutions, about integration patterns where we can use Power BI and Cosmos DB in Azure IoT. We will see how it's possible to analyze data in IoT solutions and how to create real-time dashboards. At the end, we will have some nice demos. There are different cases when we can use Power BI and Cosmos DB in IoT solutions, but let's first talk about common IoT solutions use cases. We can have different situations where IoT is something which is very useful and necessary. It is when we collect information from different devices. It is possible also to use it for monitoring of specific systems, for systems maintenance, system state reporting, and predictive analytics. As you see at the current schema, we have on the high level different sensors which communicate with backend services using different types of connections, usually via internet, using specific devices, so named IoT gateways. In IoT, we have distributed systems where we have different components in different locations, and connection and latency are pretty specific for such kind of solutions. Another important thing is that we have multi-layered architecture. That means we have different specific layers. From one side, we have devices where we have sensors, different types of connections on site, gateways, and specific other devices. We have also option to have processing on site using edge computing, and from another hand, we have also cloud where we have different backend services which can have different tasks and to have processing of information and analysis. It is very important to know that IoT solutions are data-centric. That means everything is around data, and we need to have data model and to arrange everything around our data models. We collect information from different sources. As you see, we have information which we can get from devices. It could be user-generated data. It could be data from outside systems integrated with our IoT solutions. And we can have also data which is related to identity authentication and authorization. Usually IoT solutions have more than one storage. We have from one side raw data storage, which is used for data which we ingress from different sources, from different devices, usually without specific processing. We have metadata storage, where we keep additional metadata, which is used to enrich data which we ingress. We have aggregated data storage, which is used to have processed and semi-processed data, and we have configuration data storage, where we have configurations for different parts of the solutions and common data model. And we will talk a little bit more in the context of Azure a little bit later, but you see for most of storages, We can have SQL or NoSQL solutions, and even for raw data storage, we can have simple blob storage. For the most of types of storage, it is possible to use Cosmos DB if it is configured in the proper way. Also, you should remember that Azure is a moving target. That means everything which we discuss now can be changed and can be improved during the next months and years. So everything in this presentation is actual for the current moment. But probably in the future it could be obsolete because Azure is growing and there are new and new features and new way of developing of applications. You can see Azure IoT reference architecture. You can see that we have different main components. From one side, we have IoT devices and edge devices. We have additionally Cloud Gateway, which is the main service connecting devices and backend services. We have stream processing, where we can use Azure Stream Analytics or other open source solutions for real-time and close to real-time data processing. It is also possible to have persistent in Cosmos DB or another storage for partially processed data or fully processed data for future reports. It is possible also to store not processed data for future analytics in so-named cold path storage. And from another hand, it is possible to have Power BI for several purposes. To have analytics, to have presentation, and it is possible to do the same in both cases when we have actually real-time data processing and when we have post-processing based on cold data storage. You can see on this schema that we have different alternatives for each component. We can have stream processing using different services. We can have also Cloud Gateway, which can be also alternative of Azure IoT Hub. It is possible to have Azure Event Hub. It is possible to use open source services like Kafka. It is possible to have Azure Databricks for processing or Apache Storm, and it is possible also to use different data storages, but in any case, Cosmos DB is one of the most applicable options for data persistence, and Power BI is one of the most popular options for data analytics and visualization. Let's now take a look at the different integration patterns which we have for Cosmos DB Power BI in the context of Azure IoT solutions. Cosmos DB is a database as a service which works via endpoints using a RESTful interface, so it is possible to be integrated with any other components which supports such kind of communication. About Power BI, we have some services which are useful for integration because we have direct integration. Power BI can get data directly from Azure Storage, Azure Stream Analytics, Azure Databases, Spark and Edge inside, streaming data sets, but for many other services, it is challenging to make integration and we need to have some services or custom implementation in between. Probably one of the most interesting approaches is when we have integration between other data sources and Power BI via streaming datasets. It is possible to have several different options to collect data from different sources in Power BI, especially for live dashboards, as we will see a little bit later. It is possible to have direct integration with Azure Stream Analytics. It is possible to have integration via Putnam, which is one very popular service for chat platforms and IoT. and it is possible to configure custom streaming datasets where we have different options, which we will discuss a little bit later. Let's now see options for integration. At this schema, we see one of the popular integration approaches where information from devices is stored in some storage, blob storage. It is possible with Azure functions or some other custom logics to get this data based on updates in data storage and to persist this data in some database, for example, Cosmos DB. And from Cosmos DB, Power BI can consume this data directly without any specific issues. It is possible to have the same approach, but without need to persist data in between in storage. It is possible directly using Azure functions to get data from cloud gateway and to persist it in specific database like Cosmos DB. After that, Power BI can get this data and present information in different ways. Azure Stream Analytics is another very useful option to connect Power BI and Cosmos DB with other sources, but please mind, never use Stream Analytics just to connect services. It is useful when you have also data processing. Otherwise, you will actually spend compute power only to connect services, which is not the best practice. It is possible to use Azure Stream Analytics to have output of our ingress data in different sources, different types of databases, or directly to Power BI. We can have one very interesting option, almost without development, to connect Power BI with other services using Power Automate. It is possible to have two different scenarios. In the first one, it is possible to use Power Automate to subscribe to some data alerts and to create action and to send to Power BI specific information. For the second one, actually, we can have similar scenario where Power Automate flow will have internal custom logic, and based on this logic, it is possible again to send data to Power BI. We have several options for integration also using Azure functions. In one of these options, we need to have Azure functions which will read updates from Azure storage or another storage, and based on this will update Power BI. This is probably one of the most popular scenarios. The second approach is when we have direct call from different service to Azure function. This Azure function makes some transformation and send like Power BI API updated information to Power BI. It is possible in this way to have live dashboards with streaming datasets. We will see a little bit later samples. Let's now see what kind of analysis we can have in Power BI. From one side, we can have real-time dashboards. We can have also data streaming analytics, where we can demonstrate some changes in live data. We have IoT spatial analysis. We can analyze device log. We can also analyze solution component logs. We can have predictive analytics with Power BI. We can integrate Power BI also with auto machine learning and with digital twins service. Spatial analysis are available for both powerbi.com and also Power BI desktop. Let's talk about live dashboards and real-time data. It is possible to have different scenarios where we have live dashboards. From one side, you can consider data generated from IoT sensors, which is changed. It is possible also to have some kind of analysis of stream data, which comes from different websites, like types of analysis. It is possible to stream some tweets, for example, or some data from other services with specific hashtags. It is possible to analyze stock market update on periodically with high frequency. It is possible also to have analysis on, for example, retail bank transactions. We can mention other samples. In general, many cases can be covered from Power BI live dashboard. One of the most popular cases is when we have live dashboards based on scenarios where we receive real-time data, have some transformations with stream analytics, and have output directly to Power BI. It is one of the simplest way to generate live dashboards. Power BI offers several different options for data source, which is used for real-time dashboards. One of these options is streaming datasets, which can be configured custom. It is possible also to have input from Azure Stream Analytics or from Putnam, which is service which we will cover in the demos. You will see that it is pretty easy to manage all of these cases. It is possible also to consider streaming datasets in two different ways. To have a pure streaming dataset where we have just short time persist data, or we can have also data which will be stored historically, and we will be able to have some analysis. From another hand, it is good to consider that on the context of how we send data, there is option to have pushing data to Power BI, where it is possible to make this and to keep historical data, and to have streaming data sets which are configured more detailed, and where by default we do not have historical data. We are able to create dashboards with different tiles from different sources, which looks pretty attractive. You can see on the current slide comparison between different types of data sets, and you can see that when we have Putnam, it is not possible to control the settings. When we have pull data sets, we have some limitations about the data and throughput. And when we have streaming data sets, actually we have some deep detail configurations. It is possible to configure many details, and you have actually no limits on data throughput. It is because data is not persist from a long time in our Power BI space. You can see here high-level representation of different types of real-time streaming architecture. We can have data source which is ingressed via IoT Hub or another service, and after that we can have several options. It is possible to have stream processing. It is possible to have also something which is collected via Power BI UI. It is possible to be collected also programmatically using API calls. And we can collect everything via Power BI REST API and to collect it in different types of data sets, as I already explained. Push data set, which allows also historical data, streaming data set, and pub data set, which actually is very similar to streaming dataset, but we do not have control on specific options in this case. One of the most popular options to push data in Power BI streaming datasets is to use Azure Functions. It is possible to apply this approach for almost all scenarios and almost all data sources. That's the reason to say that this approach is really very popular, and you can use it in all scenarios. Let's now see several demos. For our samples, we have a simulated device application which sends simulate data about wind speed to our Azure IoT Hub. You see here we have pretty simple messages which we use to send this information to IoT Hub, and after that to represent this information in different way in Power BI and Cosmos DB. In Microsoft Azure, I created two different Azure Stream Analytics jobs. You can see here one of these jobs actually have some transformations and sends data to Cosmos DB, and after that this information is actually used for spatial analysis, and another one is just used to send to Power BI some information which is related to our ingressed data. This is data which is stored in Power BI dataset, and it represents spatial analysis. It is done using Cosmos DB, and you can see here different locations of renting vehicles which we analyze. Here in the next sample you can see data which is actually represented like a live dashboard from our simulated device. You can see different types of simulation of visualization of this. It is possible to add different tiles where, based on data which we already have, it is possible to add specific fields from our data and to choose different type of representation for our new tile, which you see here. Next example shows us Power Automate, where we have already prepared Twitter flow. It is flow which is used to analyze different phrases from Twitter, and based on specific analysis here, for example, it is looking for tweets with Microsoft inside it like keyword, and after that this information is set to Power BI dashboard, and it is analyzed the sentiment about Microsoft word in the last tweet, and depending on different cases you can have different probability for the sentiment for the last tweet, which is change continues. Let's now see how it works with Putnam. You can create test account with Putnam, and you can create own keys and to configure with these keys actually sending and receiving of information via Putnam. I created two scripts. The first one is used to send information about cryptocurrency via Putnam to our Power BI live dashboards. It is possible to do this in simple script. This script is based on JavaScript. We have also a sample client for this script, which represents also in web browser what is the received information. That now we will see the same in Power BI. You can see here dashboard where we have information about Bitcoin price from several sources. We have this from Putnam. We have this also realized with Azure function in Azure, which reads information from specific service which offers information about Bitcoin price. That was everything in this short presentation. Thank you for being with me and enjoy the conference.